In this video, we are going to be learning about fraction addition, and I'm going to be going over all of the possible situations you might encounter when you are asked to add fractions. First, we are going to talk about adding fractions with like denominators, where the numbers are the same on the bottom. So let's just look at a really basic example. 1/5 plus 3/5. I could think about it like a picture. If I have 1/5 and I add 3/5 more, 1, 2, 3, I'm going to think about the part that's colored in. How many little parts are colored? 4 out of how many in the whole circle? 5. So in this case, my answer is 4/5. So when I have fractions that have the same denominator, the same number on the bottom of the fraction, all I have to do is add the tops or the numerators. So I do 1 plus 3 is 4, and I keep the denominator the same, 4/5. Here's an example for you to try. 2/7 plus 3/7. Take a second, see if you can figure it out. What would this equal? Well, since I have 7s in the denominators of both fractions, all I have to do is add the numerators. 2 plus 3 is 5. I keep the 7 on the bottom, so my answer is 5/7. Now here are 2 more problems to try. See if you can figure out the answer to these 2 problems. So pause the video, and when you have them figured out, you can play it again to check your answers. So these are the 2 answers that hopefully you got, 4/8 and 15/20. But now we're going to talk about how do we take this to the next step by simplifying fractions. So simplifying fractions is all about how do I take the fraction that I have and write a fraction that's equal to this but using the smallest numbers possible. So what I do in order to do this is I think about what numbers can I divide 4 and 8 by. Well, I can divide 4 by 1 and 4 and 2. For 8, I can divide by 1 and 8 and 2 and 4. So now I'll figure out what's a number I can divide both the top and bottom by. All right, so I'm going to divide by the biggest one. So I divide both the top and the bottom by 4. So then I do 4 divided by 4 is 1, 8 divided by 4 is 2. So 4/8 simplified would be 1/2. Now let me explain why we divide the top and the bottom by the same number. If I have 4/4, here it is as a picture, that's the same thing as 1 whole. If I divide a number by 1 whole, it always equals that same number. So if I divide this fraction by 4/4, that's like dividing by 1 whole. So if I divide 4/8 by 1 whole, it's going to get me a fraction that's equal, but I'm using the smallest numbers possible to get that value of the fraction, to get that equal fraction. So that's why it works to do it this way. Let's try the same thing on this next one. What numbers can I divide 15 by? 1, 15, 3, 5, how about 20? 1 and 20, 2 and 10, 4 and 5. So what are numbers I can divide both by? Okay, so I'll look at the biggest one, 5, and divide the top and the bottom by 5 because I know it's like dividing it by 1. The value of the fraction doesn't change. So 15 divided by 5 is 3. 20 divided by 5 is 4. So my most simplified fraction would be 3/4. There's not any other number I can divide 3 and 4 by to make the numbers smaller. So that is as simplified as it can be. Let's go back up to this one here, 5/7, and let's look at why this one cannot be simplified. What numbers can I divide 5 by? 1 and 5. How about 7? 1 and 7. So, in common, I have 1. So let's see what happens when I divide the top and the bottom, the 5 and the 7, by 1. So I have 5/7, I divide the top by 1, I divide the bottom by 1. 5 divided by 1 is 5, 7 divided by 1 is 7. So my fraction didn't change at all. So this is as simplified as it can be, 5/7. I cannot simplify it anymore. 5/7 is my final answer. The same is true if I have an example problem like this. Let's do, how about 7/8 plus, let's say, plus 7/8. So I have the same denominators, both of them are 8, so all I have to do is add the numerators. 7 plus 7 is 14. So now I'm going to think, what numbers can I divide 14 and 8 by? Well, 14 I can divide by 1 and 14, 2 and 7. I'll do the same thing for 8. I can divide by 1 and 8, 2 and 4. So what are the numbers I can divide both by? 1 and 2. So I'll divide by the biggest one. 14/8, divide both the top and the bottom by 2. 14 divided by 2 is 7. 8 divided by 2 is 4. So now that's as simplified as it can be. There's nothing else besides 1 that I can divide both 7 and 4 by, so that's it. But if I have a fraction like this where the number on top is bigger than the number on bottom, that's called an improper fraction. And so to get rid of an improper fraction, I can change it into a mixed number. In order to do that, what I have to do is think about how many times does 4 fit inside of 7. I can think about it as a picture. If I have 7/4, 1, 2, 3, 4, 5, 6, 7. Well, looking at this picture, it's pretty easy for me to tell. I have 1 whole and 3/4 left over. I can think about it this way too. 4 fits into 7 1 whole time. 1 whole time. With how much left over? Well, 1/4 is 4. So if I take that away from the 7, I have 3 left over. So I have 4 fits into 7 1 time with 3 left over. So I have 1 and 3/4 would be my final answer for this problem. Now we're going to look at another case of fraction addition, but this time it's when you have unlike denominators. So it would be a problem like this. 1/7 plus 1/3. These numbers in the bottom, the denominators, are not the same. So I unfortunately can't just do this. 1 plus 1 is 2, 7 plus 3 is 10, 2 tenths. No, that does not work. It does not get you the answer that you need. So let me show you how we would solve a problem like this instead. What I need to do is find equivalent fractions. So like we just talked about how we simplified fractions, similar thing, we're going to find fractions that are equivalent. They're equal to each other, but the numbers that we use on the bottom will be the same. So I need to think what multiples of 3 and 7 are the same. So if I have 7, here's the multiples of 7, 14, 21, 28, 35, etc. Multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, etc., etc. So what are some multiples that they have in common? I have 21 in both. So I could change this problem here to two fractions that have 21 in the bottom. Well, what do I have to do to each fraction to get to 21? Here, if I have 7, what do I multiply 7 by to get to 21? Well, I have to do 7 times 3. And just like what we talked about before, whatever I do on the bottom, I have to do on the top. It's just like multiplying times 1. It doesn't change anything about the value of the fraction. So 7 times 3 is 21. 1 times 3 is 3. Now I'll do the same thing with this fraction over here. To get to 21, I do 3 times 7. So I multiply by 7 in the bottom, so I'll do the same on the top. So 3 times 7 is 21. 1 times 7 is 7. So now my problem is 3 21s plus 7 21s. Now that I have the same number in the bottom, the same denominators, all I have to do is add the tops, the numerators. 3 plus 7 is 10. Then I keep 21 in the bottom, and that is all I have to do. Here are 3 more problems to try. So see if you can figure these out, pause the video, and then when you have your answers, you can check your work by playing the video again. So go ahead, pause the video now. These are the 3 answers that you should have gotten: 31 over 40, 3/4, and 5/18. So I just want to point out one more thing before we move on. So down at the bottom here, I found that the least common multiple of 6 and 9 is 18. So I multiplied 6 times 3 to get 18, 9 times 2 to get 18, and I got my answer. Now, a strategy you might have learned in the past, which also works, is to just multiply these denominators together. So I do 6 times 9 is 54. So I'm going to change my 2 fractions to a denominator of 54. So over here I did 6 times 9, so I multiplied the top by 9. 1 times 9 is 9. Then on this side I did times 6, so I multiplied the top times 6. 1 times 6 is 6. Now I add. I have the same denominator. So 9 plus 6 is 15 divided by 54. So now this fraction is technically equal to this one here, but it's not as simplified as it can be. So I'll need to simplify it. I can divide both the top and the bottom by 3, which I could figure out by finding their common factors. 15 divided by 3 is 5. 54 divided by 3 is 18. So in the end, I get the same thing. But down here, when I just multiplied the numbers together, I had to take an extra step to simplify the fraction at the end. When I just found the greatest common factor, I didn't have to simplify. So you could just multiply these 2 denominators together to get a common denominator, but sometimes in the end you will have to simplify your answer to get the most simplified fraction possible. Now we're going to talk about how to add mixed numbers. So a mixed number would be something like this: 2 and 1/5 plus 3 and 3/5. So when I have problems that have mixed numbers, anytime I have whole numbers, I just want to get rid of them because it just makes things more complicated when you have to figure out how to work with these whole numbers. I just prefer to use just 2 fractions. So I am going to change these mixed numbers to improper fractions. So to do this, I need to think about 2 and 1/5. how could I change this to an improper fraction? So here's a picture of 2 and 1/5. So I'll color it in 1, 2, and 1/5. So I'm now going to think about how many fifths I've colored in. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this fraction here, 2 and 1/5, is equal to 11/5. Here's a trick that will work to help you do this quickly without having to draw a picture every time. I can do this whole number times the denominator. So 2 times 5 gets me 10. Then I take this number and I add the numerator. So I have 10 plus 1 gets me 11. And then I'll keep the denominator the same. So 11/5. Let's try this trick with this other fraction. So I'm going to do 3 times 5 is 15, then add the numerator plus 3 equals 18. So 3 and 3/5 can be changed to 18/5. So now I will just add like normal. 11 plus 18 is 29/5. So I want to change this now to a mixed number. So I'll think about how many times does 5 fit inside of 29? Well, I know that 5 times 5 is 25. So it fits in 5 full times, and 5 times is 25. So out of 29, I can take away 25, and how much is left over? Well, if I take out 5 wholes, I take out these 25/5, I'm left with 4/5 in the end. So 5 and 4/5 is my final answer. So now we're going to look at slightly similar problems, but with just one small difference. So I have 2 more mixed numbers here, but this time the denominators are not the same. So in order to solve a problem like this, I'm going to follow all of these steps up here, except I'll have to take one more step in the end to make it have common denominators. So first thing I'm going to do is, if I have whole numbers, I want to get rid of them. So I'm going to change these mixed numbers to improper fractions. So I will do 1 times 4 to get 4. Then add the 1, get 5. So 1 and 1/4 is equal to 5/4. I'll do the same on my other fraction. 2 times 5 is 10. Then I'm going to add the 1 and get 11. So 2 and 1/5 is equal to 11/5. So now, unfortunately, I can't just straightforward add my numerators because I still don't have common denominators. So that's what I need to do next. So just like we did before, I'm going to find a number that I can use on the bottom that's the same. So in this case, I'm just going to do 4 times 5. I'll multiply them together. So I do 4 times 5 and 5 times 4, which I know is 20. So I'm going to have 2 new fractions with 20 in the denominator. So over here in this first fraction, if I multiplied the bottom by 5, that means I need to multiply the top by 5 as well. So 5 times 5, 25. Then over here in this other fraction, I multiplied the bottom by 4, so now I need to multiply the top by 4. So 11 times 4 is 44. So now I can add, because I have the same number in the bottom, common denominators. So next I need to do 25 plus 44. 5 plus 4 is 9, 2 plus 4 is 6, to get 69/20. So then my last step is I want to change it to a mixed number just like I did up here. So I will think, how many times does 20 fit inside of 69? Well, I can do 20, 40, 60. That's 3 20s. So 3 whole 20s fit inside of 69. But that only gets me to 60. I still have 9 left over. So my final answer is going to be 3 9/20, because 9 and 20, I can't divide by the same number. This is as simple as it can be, 3 9/20. I have 3 example problems of adding mixed numbers. So your job is, in a second, you'll pause the video, solve the problems, and when you think you have the answers, you can play the video again to check your answers. So go ahead, pause the video now. So now these are the 3 answers that you should have gotten. So for the first one, I went through all my work to find the mixed numbers, the improper fractions, got my answer, changed it to a mixed number. Then I noticed that 4/8 could be simplified. I can divide the top and bottom by 4. So in the end, I got 9.5. The next one, same thing, did my work to find the improper fractions, then found common denominators, added, and then changed to a mixed number in the end. Then the last one, found my improper fractions, and then I noticed to find a common denominator, all I had to do was multiply 2 times 4 to get 8. So then I had my common denominator, I added, then changed it to a mixed number. So if these were not the answers that you got, go back and check your work and see where you went wrong and how you could fix it to get the correct answer. The last concept we are going to talk about is adding more than 2 fractions. So this could be 1/2 plus 1/3 plus 1/4, etc., like that. So for these problems, we are going to solve these exactly the same way that you solved adding 2 fractions. Now we just add a 3rd fraction in the mix. So right now my denominators are not the same, so I need to find a number that I could use as a common denominator. So let's see, I could find my multiples, so 2, 4, 6, 8, 10, 12, 14, 16, etc. 3, 6, 9, 12, 15, 18, blah, blah, blah. 4, 8, 12, 16, 20, blah, blah, blah. So what is the number I have in common in all of them? 12. I could make 12 be the common denominator. So 12, something over 12 plus something over 12. So I need to think, what do I multiply each of these numbers by to get 12? Well, in this case, 2 to get 12 times 6. I multiplied the bottom by 6, so I multiplied the top by 6. 1 times 6 is 6. Now 3. 3 to get 12, I do times 4. 3 times 4 is 12. I multiply the top by 4. 1 times 4 is 4. Lastly, 4 to get 12. 4 times 3, so I multiply the top by 3 too. 1 times 3 is 3. Now that I have common denominators, I just add them all up. So 6 plus 4 is 10, plus 3 is 13, so 13/12. How many times does 12 fit inside of 13? 1, with 1/12 left over. So my answer is 1 1/12. Now, just like before when I was adding fractions and I wanted to find common denominators, I talked about how I could do this method that I'm erasing right now of finding the least common multiple and figuring out what you multiply each of them by to get that least common multiple, or else you can just multiply the numbers by each other. Same thing on this. If I have 3 numbers In the bottom, I have 2, 3, and 4. I could simply just multiply these together to get a common denominator. 2 times 3 is 6, times 4 is 24. So if I do that, then each of the fractions will have 24 in the denominator. So now this changes things slightly, because instead of figuring out what I multiply each of these by to get 12, I'll think about what I multiply each of these by to get 24. So 2 times what gets me 24? Well, 2 times 12. So I do 1 times 12 to get 12, 3 to get 24, times 8. So 1 times 8, 8, 4 to get to 24, times 6. 1 times 6 is 6. So now I add, because I have common denominators. 12 plus 8 is 20, plus 6 is 26 over 24. I can simplify. I'll divide them both by 2 and get 13/12. And now it's just the same as like what I saw up here. 12 goes into 13 one time with 1 left over. So this method works as well. You just add in the extra step of needing to simplify in the end. So either way will work. You should get the same answer in the end. This just requires an extra step. Now here are 2 more example problems for you to try. So in a second, pause the video and solve the problems, and when you have your answers, you can play it again to check those answers. So go ahead, pause the video now. In the end, these are the answers that you should have gotten after finding common denominators and simplifying. 1 and 11/30 and 1 and 71 over 168. So if you got either of these wrong, check your work, see where you went wrong, and if you can fix your mistakes. So now this is the end of the adding fractions video. Hopefully you have a better understanding of how to add fractions and you now feel more comfortable with it. So see you later.